So the next pattern would be a right-angled mirror triangle. So we have already written code to print a right-angled triangle, but this is a bit different because this is inverted and it also has spaces towards the left. So we have to print the spaces as well. As you know, the first step would be to divide the entire pattern into a matrix form, that is rows and columns, and label them. And we have labeled them as follows: R0 to R3 for rows and C0 to C3 for columns. Now these are empty spaces and they're represented by an empty block here. Now the input would be n, that is the number of rows. To print space, we need to identify the condition and the variable as well. Now let us analyze the complete pattern. Now the row loop should run 4 times and the column loop should also run 4 times, but we need a special condition to print spaces and to print stars. So let us start writing the addresses of all the cells. When R0 and C0, that is the first row, we got to print a space. When R is 0 and C is 1, a space has been printed. R is 0 and C is 2, it's again a blank space. When R is 0 and C is 3, there is a star. Now let us follow the same process for all the 4 rows. From this, we come to know that the outer row loop runs 4 times and the inner column loop also runs 4 times. So there is no relationship between rows and columns in this particular pattern. So we need to identify a separate condition to print blank spaces and stars. Now arriving at space condition, we need to write a condition to print the spaces, right? So let us go row by row. Now let us do in-depth analysis. Row 0, there are 3 spaces. Row 1, there are 2 spaces. Row 2, there is a single space. And row 3, there are 0 spaces. Okay, so now let us try to represent these spaces in terms of the input variable n. When row is 0, C, that is the column loop, should go from 0 to n minus 1. So n is actually 4 here. So 4 minus 1 is 3. So when r is 0, it should go up to 3. 0, 1, 2. And not to 3, it is up to 3. So it is less than 3. So when r is equal to 1, it should go from n minus 1 minus 1. That is, it should go up to 2. 0, 1, and this is C2. It should not go till C2. It should be less than C2. When r is equal to 2, C should go up to n minus 1 minus 2. So as you can see here, we are representing these spaces in terms of n. So 3 can be represented as n minus 1. N is 4, 4 minus 1 is 3. 2 can be represented as n minus 1 minus 1. That is 4 minus 1 is 3, minus 1 is 2. 1 can be represented as n minus 1 minus 2. That is 4 minus 1 is 3, 3 minus 2 is 1. 0 can be represented as n minus 1 minus 3. Now we have arrived at a pattern here. Can you see here? It's n minus 1 minus 0, n minus 1 minus 1, n minus 1 minus 2, n minus 1 minus 3. Now, can you derive a relation between rows and columns? Yes, as you can see here, when row is 1, there is minus 1 here. When row is 2, it is minus 2 here. When row is 3, it is minus 3 here. So for any given row, C, that is blank spaces, would go up to n minus 1 minus r. This is R, right? R row is equal to 1. This is 1. Row is equal to 2, again 2. So this is nothing but your row numbers. So this can be represented in general as n minus 1 minus r. So for any given row number, C should be less than n minus 1 minus r to print a space. If it is not less than n minus 1 minus r, you print a star. Now let us analyze the tabular method. When r is equal to 0, C is equal to 0, this is the condition that we have identified. C is less than n minus 1 minus r. Now let us substitute. So C is 0, so we substitute C by 0 here. N is always 4, so it is 4 here. 4 minus 1 minus 0. R is equal to 0 here, replaced by 0. So is 0 less than 4 minus 1 minus 0, that is 3. Is 0 less than 3? Yes, 0 is less than 3. So you need to print a space. So we have printed a space here. R0 and C0, we print a space. Now let us move on to the next cell. R is 0 and C is 1. After substitution, we get 1 less than 4 minus 1 minus 0. Is 1 less than 3? Yes, 1 is less than 3. So you print a space here. Moving on to the next cell. R is 0, C is 2. So after replacing, we get 2 less than 4 minus 1 minus 0. 2 is 2 less than 3. Yes, 2 is less than 3. Print a space. Now, moving on to the important cell. R0, C3. If we substitute, we get 3 less than 4 minus 1 minus 0. Is 3 less than 3? 3 is not less than 3. So you have to print star. Moving on to the next row. Again, after repeated substitutions, we get to know that whenever this condition is true, we print an empty space. Whenever this condition is false, you print a star. So this gives you a right-angled mirror triangle. Now, this is the code logic. R, that is rows run from 0 to 3, it must run 4 times. And column loop should also run 4 times, that is from 0 to 3. There is no change in it. But once you enter the column loop, you need to check what you have to print here. Either it is a space or is it a star. Now we have already arrived at a condition. If C, that is the column loop variable, is less than n minus 1 minus r. If it is true, then you're going to print a space. If not, you're going to print a star. Then after printing, you are going to move to a new line. Again, R will get incremented and C starts from 0 and it goes all the way up to n. It's actually less than n. Again, we start checking the condition. Is C less than n minus 1 minus r? If so, print a space. If not, print a star. So this is the code logic.